So continuing with our stock fund and our bond fund, these are the statistics that were calculated before. Yeah, we can see that stocks have a higher expected return and higher risk than do bonds. The interesting thing is, so we're gonna combine these into portfolios. So first example here is if a portfolio 50% of each, do the expected return on that portfolio is simply the weight in bonds times the expected return on bonds, and and then plus the weight in stocks multiplied by the expected return. So the so for the we'll do that for each of the cases. You can actually shortcut it. So uh, 50% 0.5 times the 7% plus 0.5 times the 11% gives you an expected return of 9%. What we get our portfolio will happen is by combining these two, we can create an expected return that's higher than what is achievable in bonds with a much lower risk. That's because those two assets are negatively correlated. That's why you see the benefits. So this is, as I mentioned, the expected return of 9% comes from 0.5 times 11% plus 0.5 times the 7%, the expected return for bonds. The portfolio variance, the formula is a little uglier than we've seen, but it's if you have a graphics calculator or you're using Excel, it's actually not too terrible. But we can calculate the portfolio variance is the weight in bonds times the standard deviation in bonds squared plus the weight in stocks times the standard deviation in bonds. And we square that, and then 2 times the weight in bonds times the standard deviation for bonds. I'm going to show you a simplification of this. This is if we take, let me get a pen here. So this is your correlation coefficient. Well, if you note, we have the standard deviation for stocks and bonds. This is equal to the covariance. The covariance return. So we can simplify this by WB, WS. So so this actually simplifies this calculation a little bit anyway. So as I mentioned, you can see the benefit or the decrease in risk that diversification offers. So equally weighted portfolio in stocks and bonds has less risk than either stocks or bonds held in isolation. So not always the case, but if we look at this, there we can see that there as we change, we've got on the left we got the percentage in stocks. So as we can actually increase the return and decrease the risk. So if we look, so as we increase the percentage in stock, we're actually decreasing the risk and increasing the expected return. So there, this it's plotted on this graph here. This just so you note, I assume this is supposed to reflect this balanced portfolio, but actually I think the dot should be here. So anyway, but we have the portfolio return here and the this risk or the standard deviation on the x-axis. So we can see as we we go the lowest risk, which would be referred to, as far as we can see, the minimum variance portfolio. Don't know if it's exactly 35%, but this is the lowest risk and offering a return of 8.4%. That's almost a risk-free portfolio. So if the two assets were perfectly negatively correlated, we could actually create a risk-free portfolio. So, so we obviously if we look down here, they're on this portion, these portfolio, there are obviously better options. There are options with the same risk that offer much greater returns. So, or slightly greater if we're looking over here. So portfolios, different correlations. So if we have a perfectly correlated portfolio, there are no benefits from diversification. But if as long as the portfolio is not perfectly correlated, we can benefit from diversification. This is what a portfolio looks like if there's a correlation of 0.2%. As I mentioned, the -1, that would be perfectly negative. This would be the risk-free portfolio that I mentioned. So the correlation, the relationship depends on the correlation coefficient, which is going to be between -1 and 1. So, as I said, if the correlation coefficient is perfect, meaning positive 1.0, there's no benefits from diversification, no risk reduction is possible. But if the portfolio is perfectly negative, we can create this risk-free portfolio. We'll start the next lecture with the efficient frontier.